In today's video, we are going to begin working on solving equations that take more than one simple step to solve. Today, we're going to focus on the first 6 problems in this new note packet. And all of these problems are going to be done the same way. Okay. We're going to spend 3 to 5 days on 2-step equations, and there are different pathways through them. For the first few days, I'm going to introduce a new path each day, and then we'll spend a couple of days just putting it all together in different types of problems so that we can make sure that we're good no matter what's put in front of us. In today's problems, our variables are going to have both a number superglued to them and another number that's just hanging out on their side of the equation. So let's take a look at number 1 and see what I mean when I say all that. We have the equation that 48 equals -7 minus 5m. Now, with that m, there are 2 other numbers on the right side of the equation, a -7 and a -5. The -5 is directly attached to the m. The -7 is just hanging out on that side of the equation. When we solve a 2-step equation, we want to do it with as little confusion as possible. Now, there's something I need to point out. Up until now, when we had to deal with multiplication and division, there was no questioning, they were 1-step equations. But something you must understand. When you multiply or when you divide in an equation, it's not that you're doing it to one thing on one side and one thing on the other side. Multiplication and division must happen to everybody. So we could try to take that -5 off of the m, but that would require us to divide 48 by -5, the 7, by -5, and our -5. And I think you can agree that a lot of that isn't going to work nicely. So we're actually not going to do that. Because multiplication or division must happen to everything, unless we're trying to get rid of a fraction as our first step, which is something we will eventually do, we're going to want to save whatever's closest to the variable for last. So let me put my line down through as usual. The first thing we got to deal with is this -7 that's hanging out on the right-hand side with m. It's a -7, so how do we get rid of it? We have to use a +7. So we're adding 7 on both sides of our equation. 48 plus 7 is 55. On the left side of our equation, the -7 and +7 cancel one another out, leaving us with just the -5m. M is not yet alone. It takes one more step to get it there, and that one step is to divide everything by -5. We have a positive divided by a negative, so our value is negative, and 55 divided by 5 is 11. In number 2, we have a 5, we have a -10 that are on the left side of this equation with the variable b. The 10, which is negative, is directly attached to the b, so it gets saved for last, which means our first target for removal is the 5. It's a +5, so we're going to subtract 5 from both sides so that we have -10b is equal to 40. Now we need to take the -10 off of the b. It is attached by multiplication, so we will utilize division to get it off. We have a positive divided by a negative, so our value is negative, and 40 divided by 10 is 4. Go ahead, if you like, pause the video, attempt numbers 3 and 4, then unpause and check them out. In number 3, our first step is to subtract 3 from each side. That will remove the 3 from the right-hand side. On the left, 3 minus 3 is 0. On the right, we're left with the negative 5r. To separate the negative 5 from the r, we will divide by it. Now, normally, you would think this is a positive divided by a negative, but it's 0 divided by something. 0 divided by anything is just 0. And 0 is not positive. 0 is not negative. It's just 0. In number 16, the first thing we're going to do is take care of this positive 4 that starts at the right-hand side. And we'll do that by subtracting 4 from both sides. That gets us 12 equals negative 4x. We will then divide both sides by that negative 4. And we will get negative 3 as the value for x. Once again, there are word problems. As before, we are going to set up an equation and then solve it. So for a field trip, 7 students rode in cars and the rest filled 9 buses. How many students were in each bus if 367 students were on the trip? Well, okay. Let's start with car riders plus bus riders equals total students. We know how many car riders there are. There are 7. We don't know how many bus riders there are, but we know that there were 9 buses. And we're going to assume that they were equally across those 9 buses. So that means we have 9 buses worth of students. So I'm going to switch my B to an S just to represent the idea of students. And T is the total number of people on the trip. That's 367. Two-step equation. Subtract 7 from both sides so that we get 9s equals 360. Then we can divide both sides by 9 so that s is equal to, again, the old trick. Take that 0 off of 360, stick it in your pocket. 36 divided by 9 is 4. Then take that 0 back out of your pocket and put it on with the 4. There were 40 students on each bus. Number 6 is set up with the same type of wording, so I invite you to pause the video and take a stab at it. We have 13 students riding in cars, and the rest of the students filling 4 buses. So 4 times however many students are on one bus. And we know there were a total of 113 students on the trip. We will subtract 13 from each side of this two-step equation to get 4s equals 100. And then we'll divide both sides of this by 4 to find that for this group, there were 25 students per bus.